In today's lesson, we will focus on trigonometry. Don't let the word scare you. It just means triangle measurement or the study of triangle measurement. Basically, trigonometry is the study of relationships between sides and angles in right triangles. All triangles actually, but right triangles specifically for what we're doing today. A trigonometric ratio is a comparison of two sides of the triangle or a ratio of their lengths. There are three basic trigonometric ratios that we work with in right triangles. The first one is called the sine. The sine is the ratio of the opposite side over the hypotenuse. Now, these are referring to the opposite side to a specific angle and the hypotenuse for the triangle. Now, we abbreviate sine, S-I-N, with the first three letters. Following that would be an angle. So if I say sine A, then what I'm referring to is the opposite side from angle A and the hypotenuse of the triangle. The second trigonometric ratio is cosine, and cosine is abbreviated COS. So again, if I'm referring to angle A, cos A or cosine of A is the adjacent side to angle A over the hypotenuse. The third ratio is called the tangent, and again abbreviated with three letters. So it would be tan and then the angle, which in our case is A, and the tangent ratio is the opposite side from A to the adjacent side to A. So again, everything is with respect to a given angle. Now, in addition to the three functions, in every problem we work both forwards and backwards. We have arc functions, which actually take the problems and work them backwards. This, to do it on your calculator, you hit second and the key, and it looks like either arc sine with the word or sine and a -1 power, arc cosine or cosine to the -1st power, and arc tangent or tangent to the -1st power. These are the inverse operations, and what they are used for is actually to find the measure of an angle if you know the sides of a triangle. Now, we are going to be finding trigonometric ratios when you know the lengths of the sides, and the key to this again is it is always done in relationship to a specific angle. So let's take a look at our first example. The first thing is we have to identify the angle we're working with, and this says find them for angle A. So here is angle A up here, and I need to identify my sides in relation to angle A. The first side's easy. It's the hypotenuse. It's always the longest side of the right triangle, and it's always opposite the right angle. The second easiest side to find is the opposite side. If you start at angle A and draw a line or an arrow through the triangle, it points to the opposite side, and then the third side has to be the adjacent side. Now, to do this, we are simply going to fill in these answers into the appropriate relationships. Now, there is a way to help remember these relationships. It's called SO, CA, TOA. And what SOHCA TOA means, it's, like I said, it's a way to remember. So the sine is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and the tangent is the relationship of the opposite side over the adjacent side. So, first thing we did down here is we found our angle and we identified our sides as opposite, adjacent, and hypotenuse. 12 was opposite, 5 was adjacent, 13 was hypotenuse. So to find the sine of A, sine is so it was opposite over hypotenuse. So the opposite side was 12, the hypotenuse was 13. As a fraction, it's 12/13. As a decimal, we always round our decimals on trigonometric ratios to 4 decimal places, so about 0.9231. Now, the cosine was CA, or adjacent over hypotenuse, and you can already see that I started with 5/13, and 5/13 in decimal form was 0.3846, and the last one is tangent or TOA, which is opposite over adjacent. The opposite side was 12, the adjacent side was 5, So the tangent for this problem is 2.4. Since it was an exact decimal, I didn't need approximate signs, and I was able to go to 1 decimal place. Now, you could do the same triangle, only this time if you're shooting for angle B. So you have to identify your sides again. In this case, 12 is no longer the opposite side. The opposite side is 5. The adjacent side is 12. The hypotenuse is still 13. So we simply fill in the numbers and write the ratios. So for sine, it was 5 over 13, about 0.3846. For cosine, it was 12 over 13, about 0.9231. And for tangent, instead of 12 over 5, it was 5 over 12, which is about 0.4167. Now, I would hope that you could see one cool relationship here, and that is within the same triangle, the sine of one angle is going to be the cosine of the other angle because the sides simply change position. Now, for angle C, the right angle in the triangle, you actually cannot find the trigonometric ratios. And one thing I would like you to do is, on a separate sheet of paper, I would like you to answer that question. Why do you think you can't find the trigonometric ratios for the right angle in a right triangle? Now let's take a look at one where you have most of the information but you're missing a piece. It's actually very simple. The first thing you have to do is Pythagorean theorem. You can follow along. This is actually already on your page. So I was looking for angle R, and in angle R I already knew 18 was the hypotenuse. I knew 12 was adjacent, but I was missing the opposite side. So I simply set up Pythagorean theorem. A squared plus B squared equals C squared. Remember, 18 had to be the hypotenuse, or C. Did the work. P squared plus 12 squared equaled 18 squared. Did my arithmetic. 12 squared was 144. 18 squared was 324. Subtracted. Did my square root and came up with two answers. The exact answer, which is 6 square roots of 5, and the approximate answer, which is 13.4. We always want to use the exact answers in our work because we don't want to get errors due to rounding. You can see over here where I simply substituted in the numbers. 6 square roots of 5 over 18. I was able to cancel the 6 with the 18 and get the square root of 5 over 3, which is the exact answer. Cosine 12 over 18, 2/3, or 0.6667. And the last one, 6 square roots of 5 over 12. I was able to cancel the 6 into the 12 and get the square root of 5 over 2 for the exact answer. Our next skill is to find a missing side if you know one of the acute angles in the right triangle. Again, you have to find those relationships with what you have. So let's take a look at our example. In triangle C with right angle at A, angle C was 40 degrees. So the angle that I know about down here is angle C. So I need to identify what's missing. What's missing was AT. AT is opposite. What's missing is CT. CT is the hypotenuse. The side I actually knew was the adjacent side. So I started by looking at finding the opposite side. So I looked at the information I had. I had the 40-degree angle. I was looking for the opposite side, and I knew the adjacent side. So I knew I was referring to opposite and adjacent, or out of SOHCAHTOA, I was looking for TOA or tangent. So I set up my problem. The tangent of 40 equaled AT over 15. To solve it, it was a fraction, so I multiplied both sides by 15 to eliminate the denominator. Multiplied that out on my calculator and got about 12.6. We usually go 1 decimal place for sides. We usually round our sides to the nearest tenth. Now, one thing I hope you noticed is I did not turn tangent 40 into a decimal and round it off and then must multiply. You want everything to be as exact as possible, so what you want to do is solve the problem so that it's calculator ready, and then just simply punch the numbers into your calculator. This means we need to talk about your calculators for a minute. When you look at your calculator, one of the things that has to be true on your calculator is you have to be in the correct mode. And the mode you need to be in is degree mode. So everybody take your calculators out, turn it on, and push the mode key. When you push mode, you should see a list of different modes: normal, float, radian, function, connected, and so on. You want to be in degree mode. That's the third one down, so you would arrow down. If yours is highlighted on radian, then you want to arrow out to degree. You want this one to be highlighted in black, and then press enter. That will put your calculator in degree mode. Now, to actually solve the problem, what we need to do is just punch it straight into your calculator, 15, and then we'll hit the tangent key, which is right above this right-hand parentheses, and then 40, because that was the angle, and then close the parentheses and hit enter. And you can see that we got a side of 12.6 units. Now, moving on to the other missing side. The other missing side was the hypotenuse, which was CT. Again, I always refer back to the side that I know the exact answer for. I don't want anything that I've already rounded, so I went back to the 15. So I had hypotenuse and adjacent. The piece for hypotenuse and adjacent is cosine. So I set up my problem with the cosine of 40 equaled 15 over CT. Again, I'm working with a fraction, and because I'm working with a fraction, I wanted to get rid of it first, so I multiplied both sides by CT to eliminate all of my fractions. But then I had a problem. CT was not alone. It was multiplied by the cosine of 40, so I divided both sides by the cosine of 40 degrees. Again, this is a calculator problem at this point, and 15 divided by the cosine of 40 degrees worked out to about 19.6. That gave me the hypotenuse of my triangle. The next thing we had to do was we actually had to go back and find the missing angle. I already knew I had a 90-degree angle. I already knew I had a 40-degree angle, and I know that the angles in a triangle add to 180. So I simply added the two angles I knew together, subtracted from 180, and got my missing side to be 50 degrees, or missing angle to be 50 degrees. Now, we come to the last situation, which is how do you go from the sides to the angle? So, in this case, we're going to be using that arc function, or the inverse function on your calculator. So let's take a look at our first example. In our first example, I know that the sine of A was 3/5. I don't want the sine of A, I want the actual measurement for angle A. So to do this, I'm going to use my calculator, and this is an equation, so do unto one side as you do unto the other. I'm going to take the arc sine of both sides of the problem. This is the notation. This is what the notation would look like. Arc sine and sine cancel each other out, so I'm left with angle A on the left, and on the right, all I do is simply push in second sine. These are my keystrokes, second, and then the sine key, and then I just type in 3 divided by 5, and it gives me an answer of approximately 36.9 degrees. Now, we can actually do the same thing from a figure, and when we do it from the figure, we have to identify the parts. If we're looking for angle A, I need to know that 14 was adjacent, 20 was the hypotenuse, so I had adjacent and hypotenuse. So with adjacent and hypotenuse, I'm going to be using cosine. So I know that the cosine of A equals 14 over 20. To solve it, I'm going to take the arc cosine of both sides, and that will give me my answer. And we can do that on our calculators very simply. And our measurement for angle A is 45.6 degrees. This concludes today's podcast.